obviously, every day, I'm closer to my death. Nothing's wrong here, right? But today I was extremely close. I was in the gym. I was bench pressing. And on the 16th rep, I failed. As soon as I failed, the bar with the 125 kilos on it fell on my chest. However, I knew that I had to go here to be here. That's why I decided not to die, which wasn't an easy decision. I decided to roll over the bar over me. And I did that. So that's why I'm here. Thank you very much for saving my life. So I'm here for two reasons. First of all, I was invited, and thank you very much for invitation. And the second reason is that I'm writing a book at the moment, and I'm here to promote the book. So the book will be ready, hopefully in August this year. But it will be available in the early access, hopefully in the next 2 to 3 weeks. Buy the book. Buy the book. So there are many chapters in this book, but today we will briefly talk about metrics and losses in machine learning system. There is also a chapter about design doc example, which we might discuss later. Probably most of the people here have ever tried to train the machine learning model. It is, I suppose, a safe assumption, right? Otherwise, what are you doing here? Which is basically a good question to ask yourself, what am I doing here? Like, at any given moment. And you know that it's very hard and almost impossible to train your model without a proper loss function, right? So let's start with a simple definition, and then we will see how just a simple choice between two very basic loss functions can drastically affect the output of your models. And I'll tell you a cool story how 5 years ago an agency hasn't received a 2 billion ruble contract because they picked the wrong function. It's a very important topic. Well, because I was among the people who had to decide would they have it or not, and they failed. So the loss function, it's basic definition, right? Let me read it. Also known as the objective or cost function. It effectively defines how a model learns about the world and connections between dependent and independent variables. What it pays most attention to, what it tries to avoid, and what it considers acceptable. Thus, the choice of the loss function can drastically affect your model's overall performance. Even if everything else, features, target, model architecture, data set size, they remain unchanged. And there are two requirements for the loss function. Be globally continuous. Changes in predictions lead to changes in losses. And be differentiable, because usually we optimize using a gradient descent. Now, why is it important? Why it's important to pick the loss function? By the way, maybe you know an answer and I can skip it? No, you don't know the answer. You can't. There is no answer here. Answer is in my head. That's why I'm more valuable than this slide. And even all the slides here, I'm more valuable, trust me. So why is the loss function important? Right, so like a previous speaker said, when we train the model, and they train the model is a different thing. Then we train the model, we try to do what? To solve some specific business task, right? So, and usually the easiest task to understand is to make more money. Because if you have a manager or founder or owner or whoever, and you could prove that you brought more money, probably better, like you bring more money than this person spent on you and your team. This is good, right? So you probably wouldn't go to your manager and tell, oh, look, our AUC is now 96, it was 95, so what the hell does it matter, right? But you still train the model using the loss function. So your loss function has to be directed in the same point as your end goal, right? So for example, let's say we need to block the spam messages, and we know that there is binary classification problem, and we know that we have a spam and non-spam messages, and we have some labels. But effectively, we don't care how good our model is. We care about the users. If users are happy, that's good. They're not happy because of the spam, it's not good, right? So that's then. But unfortunately, we can't measure user happiness. But we can try to find a metric which is very correlated with user happiness, and then we can try to find a loss function, or ideally the loss function is equal to the metric. Sometimes that happens, which is correlated and co-directed with our goal, right? So let's take a very brief and toy example. Let's say we have a vector of target values, just 10 samples. Does it have, I don't know, every time I push the button on things like that, on clicker, something wrong happens. All right. not that bad. So you can see like 100, 100, 100, 100, 100, 1,000. 10 samples, very easy, right? Now, we change nothing. No data sample is the same, model is the same, everything is the same, features are the same. The only thing we do, we train the model using mean squared error, which is, let's try to remember, it's like yi minus y hat I squared I, right, something like that. Correct? Am I? Yeah, so there is, it's not RMSE, so it's MSE, so I don't have to take a square root. Okay, so good. And we try to remember, would be very shameful for me to fail, right? Is there a video recording? But yeah, basically you can see it's like a squared residuals, an average over the number of samples. We can obviously take a root, but it doesn't change anything, to be honest. Or mean absolute error, which, as we can see, absolute. So instead of making a power of 2, it's just modulus. All right, so we use that. Here are our results. 190, 190, 190, 190, tra-ta-ta-ta-ta. Why? I'll tell you later. Maybe you have an assumption why. Go on.
In this case, the cost of our mistake is higher than in the metric of MSE. And that's why the cost of our last number, 1,000, it's just destroy all of our...
Good. Why?
Because of metrics.
Yeah, of course it's because of metrics, because I told you it's like we use different loss function. Why they're different? Because they're different, right? Okay, good answer. Now, let's give a second chance. But I'll remember you. I saw someone. Yeah, yes, please. No feature scaling.
Small amount of targets?
No. This guy was very close. Go on. Right, so yeah, because here we're optimizing the mean, an average, right? So if you think about that, what we're trying to optimize, we're trying to optimize the mean output features. In case what we're trying to optimize is Median, right, okay, and now if you take a look here, or we'll take a look later, we can even plot that. So, what is the residual? 90, right? The difference is 90 all the time. 90. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Residuals. No. So, what is our mean residual? 90. What is our median residual? 90. Cool. What did we optimize? Mean. Now, we take a look in the second one. We can see that now it's 10 hundredths, right? Oh, actually, I lied to you and you agreed with me because 190 and 1000 is not 90, the difference between them, right? So probably the difference between them is like something like, let's say it's 810, agree? So now we can say that the median residual is 90. Well, that depends how you count, because it's actually, to be honest, if it's like 100 minus 190, it's minus 90, right? So we have to, so it's minus 90. I can do that. And this is 0. So the median residual is minus 90. And the mean residual is what? Zero. Why? Minus 90 times 9. Minus 810, correct? Plus 810, 0. So mean residual is 0. Cool. We did optimize for mean. We had a 0. The mean is 0. Cool. Now, let's say a different example. Now, instead of just plotting another chart, I will use axes or crosses instead of dots. So what do I have here? 9 residuals are 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 is what? 900. Right? 900. What is the median residual? 0. Cool. Much better, right? In case of median. What is the mean residual?
90.
Right. 90. So you see, just placing this different loss function provide us a different result. So now the story. How did those people paid and received 2 billion contract? So there was an agency. And this agency, the goal was to predict how many people will come if we spend some money on marketing, right? And ask him, all right, but what would you use to optimize your models? How would you look at that? And they said, oh, no props. We'll use mean squared error. A mean squared error is fine if you are very concerned about outliers. Why? If you can see that it tries to shift, well, I have that technology. It tries to shift all your output towards this one. This is an outlier, right? While absolute error tries to optimize the median. So if we try to predict how many people we would have, we probably want to understand how many would come in like a given year. We don't care if one day we made a mistake, right? We just want to increase the volume. And so, but they said, okay, mean squared error. I give them a chance. I ask you, are you sure? Because, well, I mean, you would pay more attention to outliers. And then they said, no worries, we will take a square root. So if you take the square root, it's essentially the same. I mean, it doesn't matter if like it was, what, 90, 90, 90. You take the square root, it's still bigger. It still tries to move your distribution, to shift it towards the given thing. Yeah, so, and we can see that numerically. That basically what we just provided here is when we calculate the MSE and MAE, I don't know how you pronounce it, to be honest. MAE, MSE, MAE, 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 MAE is too long, MSE, MSE, MAE, all right, MAE. So, yeah, the same. MSE is 72.9. MAE is 162. So if we optimize for MAE, we can see that MSE is higher, but MAE is lower, which is actually okay. Yeah, I need to fix that. There is a mistake here. It's MAE is obviously 0 here. Yeah, I need to fix that in the book before it's published, right? Have to remember that. Now, we could discuss many other things like a proper scoring function, that the model ideally has to be calibrated, etc., 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 right? We won't do that. How much time do I have?
10 minutes.
10 minutes. Oh, that's enough. Metrics. Yeah, we might try to pull ourselves from the swamp using our own hairs. So the thing is that the loss function we optimize and the metric we use to assess our model's performance can be very, very different from each other. Well, for example, in the book I provided the demand forecast example. And the fictional company Super Mega Retail doesn't exist. And the goal is to reduce the gap between delivered and sold items, making it as narrow as possible by avoiding an out-of-stock situation. So if you're in retail or whatever business you are, and you have a demand forecast system, essentially what your goal is to narrow the gap between how much did you buy and how much did you sell, right? So you don't want to buy 1,000 items and sell 100 items, so you just have 900. But also, you don't want to buy 100 items and then there is a demand for 1,000 items and they go to your competitor. Good. So if you think about that, you have a loss function, then you have a proxy or offline metric, because again, your end goal is to narrow the gap between sold and bought, right? But you don't have this data. You don't know, you don't know the future. You know only after it's released, launched, time passed. That you can use different metrics, like whatever you want to do. You can try to see historically. But again, let's say that. Let's say you have an ideal model, and the model predicted that there will be 1,000 items demand. And you're in retail and you order 1,000 items and you were able to sell only 900, right? So your model is wrong, but the first assumption is ideal. What happened? Let's say the easy thing happened. There is a warehouse at the shop and there is a shelf. And there is a delay between people might take the item from warehouse and put it on the shelf. Maybe there was so high demand, they didn't have enough time to do that, and that's why they didn't sell it, right? There was a request, there was a demand. Another thing, let's say you ordered 1,000 and customers bought 1,000. But you never know, maybe they would buy 1,010. Or maybe 1,000 was ideal. You never know, right? Maybe it would be 1,001 or 2,000. So you always have to have an overstock. You'd like to have more items than you really will sell, but the margin has to be very narrow. So for that, you can use an online metrics, like so you have your proxy metrics, like whatever, it doesn't matter. Like the things you can calculate offline. An online metric, which helps you to assess a model's performance in the wild. So basically, how much did they predict they will buy? How much did they actually buy? And then the final goal is to measure the success and like, did we narrow the gap? And basically what you'd like to do, you'd like to convert that to money. The best metric. Everybody understands money, right? Everybody like. If you tell me like my model achieved Huber loss of 0.1, so what the hell are you talking about, right? But my model brought an additional $10 million. Well, I understand that very, very easily. Can we do 11? The next question is. We don't have that much time, right? Sorry, these 10 minutes. These 10 minutes, do they include the time for questions?
Yeah, fine.
Yeah, let's go to the question answer. So, that doesn't matter. Metric hierarchy. The link to buy the book coming soon. My linked profile, my Telegram channel. Please subscribe. Now I'm ready to answer your questions. I didn't tell who I am. Right?
Everybody knows.
Everybody knows. Okay.
Yes.
So like, hi. Let's listen to me. Who are you? Like, it's the second most popular question after, what am I doing here? Who are you? Well, it depends. Like, it makes sense. Why am I here? And who is this guy? Right, go on. You have 4 minutes, I guess.
Yeah, okay.
Sure.
Differences with full data sets and actual imbalance of data sets.
Yeah, I mean, probably these kind people will share a presentation, because here, I just try to dissect the example. Then we have unbalanced or class imbalance situation. So I don't know why people like to use precision and recall when they work with the binary classification. This is very, very wrong, and very easy to show why. Because, well, if you work with class imbalance, you'd like to be independent of class imbalance, right? But if you take a precision, you can see that it's basically, it depends on both true positive, which is a class 1, false positive, which is class 0, right? If something depends on both, it is not class balance independent. So you have to use metrics which are, well, it's just some proof and some example. Like, but yeah, so read the book. What do I suggest?
Yes.
Well, it depends on your goal, but so I prefer to use specificity at a given recall. So you fixate the recall, because you probably need some recall anyway, and then you try to increase your specificity as far as you understand, but you also have to think about your model as in a probabilistic term. Because basically it's always a probability. Go on. From a friend. Okay. Sounds like a Wheel of Fortune, this TV show.
I am underfit. What are the most important metrics I should consider while training at the gym to become fit? Without being overfit.
Well,
I try to increase daily active protein shakes, but my monthly profit drops significantly.
So the most important metric is longevity and health. I would say so. It's hard to measure, as any long-term metric which is hard to measure. I suggest to build a hierarchy of metrics to find a proxy metric and try to optimize the proxy metric, which is A, easiest to optimize, which is one usually in the worst condition, because it's very easy to go from low baseline, and B, which you can measure. All right. We probably have 2 more minutes, 2 more questions, right? Okay, go on.
My name is Valeriy, and let's make it more funnier.
Even more.
Like, it's what you're saying, it's traditional ML work, and now we have like large language models that try to measure from complexity or something like that. And how are you seeing the future of these models? Like with the recent GPT paper, we get a bunch of SAP scores or something like other.
All right, 2 things. All right, I got it. All right, so maybe I didn't. You tell me after answer. So first, doesn't matter with the loss function metrics, because if you think about that, what GPT tries to do, it tries to predict the probability of the distribution of tokens. For that, it probably tries to optimize some loss function, which has to be a proper scoring function because to output the real probability, A. And even if you take a look at the recent paper of how they've done this fine-tuning using reinforcement learning human feedback, which is still, people have a very vigorous discussion, do they really need a reinforcement learning or not? They use what? KL divergence. I mean, it doesn't matter. People were using KL divergence 30 years ago. So in terms of loss function or metrics, nothing changed here. Now, if we want to talk about the coming doomsday and end of the world, let's say you're a machine learning engineer and you work in the company like, I don't know, I worked in Facebook. I didn't work at that many companies, but I work in Facebook. So out of 52 weeks you have within a year, 5 weeks you have as a vacation. How many hours or days you spend on building the model? I don't know, 1, 2, never. So your work is to create the pipelines, find the proper metrics, measure, run A/B tests, etc. So basically, if you have all that, yeah, sure, go on. But it's like we are talking about, oh, can the GPT, which does a 1 week job out of 52, could replace me? Probably not. Well, if it will be doing 51 weeks of job out of 52, that's dangerous. If it's doing only 1 or 0, that's not dangerous. So, I mean, right, last question. You see, it's like a benefit of being very close to the speaker.
Yeah, speaking of metrics, have you had a situation when, for example, of course, you are solving business tasks, business requests, and have you had an experience when business requests to use a particular metric, and this is not the same as you think is a better metric, and they force you, for example, to use that one?
Well, that's why I go to the gym, to force them to do the things I'd like them to do. Well, of course, because it's usual situation, oh, we're used to do this in that way, like an agency, for example. But are you asking me what to do in this case, or did I have this kind of situation? Well, actually, I already answered your question, because the question was, did I have this kind of situation? I did, answered.
Yeah, just to share your experience and how to handle such situations.
Well, that depends. If you have a reasonable and calm people working with you, you probably have some reasons why you think another loss function is better. And they also might have their reasons. And this is where the conversation starts, right? So like I have, well, probably you're not coming to, hey chaps, my loss function is 10 times better than yours, it's crap. Not a good introduction, right? But if you have a proper conversation, like guys, I think that the loss function we're using is probably not the best because of this, this and that. To mitigate that, I propose we're using this, it will solve this and that. But to achieve that, it will require this and that. Now we can make a decision, right? It's always a trade-offs. Okay, maybe you have to like completely change all your pipelines, and the way the top management receive their reports would change, etc. But it's okay. It's okay to change the metric or loss function. I mean, Rostad does it every year. Why not? Probably they don't have that kind of problem. All right, thank you very much. I think that's it. Strip me off.